You're leaning on a table, maybe sipping coffee. It feels solid, but that mug should fall right through the table. How is that even possible?
Because, Peter, the reality is that 99.9% of everything is nothing. The universe is tricking you. This table, your body, they are mostly vast empty space. This is the ultimate paradox. A world built on emptiness but feels so solid.
It sounds insane, but if our world is mostly empty space, what are the tiny things that keep it from collapsing? We need to meet the components that are fighting this fundamental chaos. Before we break down the atom, Dr. Finch, this concept of a tiny, indivisible unit has been around for centuries, right? It's not just modern science wrestling with this.
Absolutely. This chaos is ancient. Back in the 5th century BC, the Greek philosopher Democritus was the first to propose the concept. He said that if you cut something enough times, you'd eventually hit a piece that was uncuttable. But his entire theory was just a philosophical guess. They just thought atoms were these hard little balls that bounced around. It was a chaotic, beautiful idea, but it was just a theory for 2,000 years.
So we had the solid ball for 2,000 years. The real chaos began when J.J. Thomson proved the atom was not indivisible when he found the electron, a tiny piece inside the ball.
Exactly. Thomson proposed the plum pudding model, a positive goo with negative electrons scattered inside. But then came the experiment that shattered the very idea of solidity and opened the door to true emptiness, known as Rutherford's gold foil experiment. They fired tiny positive alpha particles at a thin sheet of gold. Based on Thomson's solid, spread-out model, every single particle should have gone straight through. What actually happened was so bizarre. Rutherford said it was like firing a 15-inch shell at tissue paper and having it bounce back.
Which meant the atom wasn't a solid sphere at all. It meant the vast majority of the atom was empty space, and all the mass, all the order, was concentrated in a tiny, dense, positively charged nucleus.
The atom is a structure built entirely on paradox. At its core is the nucleus, the dense, tiny powerhouse. If the atom were a major city, the nucleus would be a single grain of sand at its center, yet it contains 99.9% of the atom's mass. Meet the protons. They carry the positive charge, and their number is the atom's immutable ID, the atomic number. 6 protons, it's carbon. 7, it's nitrogen. But here is the chaos. They are violently repelling. Electromagnetism demands they fly apart.
Wait, hold on. If that core is full of things that hate each other, why does it stay together? Shouldn't every element heavier than hydrogen explode immediately?
To prevent that catastrophe, we need the neutrons. They are neutral, zero, silent, and essential. They act as the nuclear cement, spacing out the positive protons just enough to lower the electromagnetic repulsion and stabilize the core. But even the neutrons are fickle. Change the count of neutrons, and you change the isotope. Carbon-12 is stable. Carbon-14 is not. It's the same element, but the slightest change in the buffer can turn it into an unstable, radioactive disaster. And orbiting this dense, chaotic core are the electrons. They are the negative charge, and they are tiny. It takes nearly 2,000 electrons to equal the mass of a single proton. They are frantic, flying, and desperate to collapse into the positive nucleus.
Wait, let's go back to the nucleus and the electrons. They have opposite charges, right? In the classical world, opposite charges attract. That positive nucleus should be an irresistible magnet, forcing those negative electrons to spiral inward and crash. Why doesn't the atom instantly collapse?
According to the physics of the 19th century, the classical rules that govern everything we see, that atom should be a chaotic, short-lived disaster. It should collapse in a tiny fraction of a second. Order, as we knew it, said the atom couldn't exist. The only reason the atom is stable is because it's governed by a totally new set of rules. quantum mechanics. This is the ultimate order fighting the chaos of electromagnetic attraction. The electrons aren't orbiting like tiny planets. They are forced into discrete, stable energy levels. More specifically, the order is maintained by an unbreakable rule called the Pauli exclusion principle. It states that two electrons cannot occupy the exact same quantum state. They can't be in the exact same spot at the same time.
So the nucleus wants the electrons to collapse into it, but the quantum rules create an immovable, invisible wall around the nucleus. The collapse is mathematically forbidden. So let's bring it back to the coffee mug. If the atom is 99.999% empty space, and the electron is just a high-speed blur, why don't my fingers just pass right through this handle? What is the real resistance I feel?
The resistance you feel isn't solidity. It's the electromagnetic force. This force is the ultimate order maker in your everyday world. It governs light, electricity, chemistry, and most importantly, it dictates the rules of repulsion. Remember those electrons. They are all negatively charged. When you try to touch the mug, your electrons, in your fingers, come into contact with the mug's electrons, in the ceramic. And because identical charges violently repel each other, you never actually touch the mug.
So the solidity is an illusion. It's the distance between the nearest electrons, maintained by this violent repulsion, that makes the mug feel solid. My hand is just getting infinitely close to the mug's boundary layer.
Exactly. Everything you think is solid, your chair, your desk, even your own bones, is merely a highly organized, high-speed quantum dance of nothingness, maintained by a fundamental force that creates distance out of chaos. So, Peter, the reality of the coffee mug is this. It's not solid. It's a vast, empty field of nothingness, maintained by a tiny, impossible nucleus that's desperately trying to collapse, surrounded by an invisible quantum blur that creates a violent, non-contact barrier.
It sounds less like physics and more like a cosmic negotiation. The only reason this chair doesn't implode or dissolve right now is because an invisible set of rules, a quantum order, is forcing the subatomic chaos into a fixed, stable pattern.
Exactly. The world you perceive as stable and predictable is actually built on a razor's edge. A constant, violent fight between the forces of collapse and the forces of repulsion. Every object, every molecule, every moment of your life is a temporary, improbable victory of order over entropy.
That's a powerful thought to leave you with. If you enjoyed this breakdown, make sure to like this video and subscribe to Entropy Overload.